Hi friends, welcome to my channel. Let's have a look at problem 82, remove duplicates from sorted list 2. So in this video, we're going to share a solution based on linear traversal of linked list. So our purpose is to practice the use of auxiliary nodes and do repointing. So first, I'll read through the statement of the problem, and then we do some simple analysis, and finally we share the code. First, let's look at the statement. So given the head of a sorted linked list, so we are required to delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. So we are required to return the linked list sorted as well. So here are two examples. So in example 1, so we saw that 3 and 4 have duplicates. So after the deletion, so all the occurrences of 3 and 4 disappear. So we get 1, 2, 5. So similarly in example 2, so the node value 1 is duplicated. So after the deletion, so we get 2 and 3. So the additional constraints or assumptions on this problem are the following. First, the number of nodes in the list is in the range 0 and 300. Notice that the linked list itself can be null. Secondly, the element or the node value is in the range negative 100 and positive 100. And thirdly, the list is guaranteed to be sorted in ascending order. So the last one actually is basically a consistency assumption. So with that said, actually we have digested the problem requirement. So what we are going to do here is to do linear traversal of linked list. But in order to finish the task specified in this main statement of problem, so we are going to use auxiliary nodes and do repointing. So here the question requires to remove all duplicates, not leaving only one of those duplicates like in Leetcode 83. So here we're going to use two auxiliary nodes for this task. So this brings us convenience. So with that said, let's look at the code. So first, I'm going to make some preparations. So here, I'm going to use two dummy nodes. So I'm going to start from dummy 2. So it's a list node. So I'm going to use its value to be negative 101. So like here, because of the range is in between negative 100 and positive 100. So I'll let this one pointing to the head. And then I'm going to introduce another dummy node called dummy 1. So it's a list node. So the value, I'll call its value to be, say, 102. So I'm going to let it point to dummy 2. So this is the preparation step. So we created two dummy nodes and then do some connections. So the logic is that dummy 1 points to dummy 2 and dummy 2 points to head. So with that finished, so we are going to do the actual work. So in other words, we are going to do linear traversal and do repointing. So this is actually a routine task, but here because we need to remove all duplicates, so let's introduce three variables. First is grandparents, grandfather, or previous or father, and the current. So this to be the dummy 1, dummy 2, and head. So then basically the traversal is a while loop. So first I'm going to consider a simple case. That is, the current value does not equal to a previous value. So in this case, what we are going to do is that we move the grandfather and the previous or the father and the current to the next level. So that is grandfather to be previous, and the previous to be current, and the current to be current next. So notice that this operation is valid because the condition current is not null. So this is the easy case. So let's look at the harder case. The harder case is the main logic for this problem. So in other words, so we have current value and the previous value are the same. So in this case, we need to do another while loop to move the current to an extent to such that the current value does not equal to the previous value. So basically, the while loop is current. So we need to make sure the current is not null and current value does not equals to previous value, right? So the second condition after the add can be checked only if current is not null, right? So this is the whole condition where current and the current value equals to previous value. So in this case, so what we are going to do is that we push a current to current next. So we keep others fixed. So at this current stage. So then after this while loop, so we have two possibilities. First, current is null. So in this case, basically we're done. So other case is that current is not null, but the current value does not equal to the previous value anymore. So in either cases, we can do the following. So we can set the grandfather next to be the current and the previous to be current. So here, this is the grandfather, not girlfriend. So next, what we are going to do is that if current is not null, then we can reset the current state to be current next. Then continue the chain again. So that's the main logic for this problem. So after this, we are going to prepare the return. So the return is nothing but dummy one next. So here, because we have used two dummy nodes, so that's the A format of solution to this problem. Let's do a special case check. Yeah, it passes the first example, I guess. So now let's do a generic case check. Yeah, it passes all the generic cases. So this problem is, I feel it's slightly complex than Leetcode 83. But here, the thing or the trick we used is to introduce two dummy nodes in order to do the reset. So with that said, I guess that's about it for this video. Thank you very much.